The subject of Chapter 5 is polynomial equations, with 5.1 focusing on operations with polynomials, in particular exponent rules. Now this is material that you covered back in Algebra 1, although there are a lot of rules and they can be hard to keep track of. So let's refresh on the main points. First off, when we have product of powers, a monomial times a monomial, so a to the x times a to the y power, they have the same base. The base is what the exponent is attached to. In this case, it's a. And in this case, we're just going to add these two exponents together. And our answer would be a to the x plus y power. Power of a power. Here we have a monomial with an exponent there that's being raised to another power. So it's inside parentheses, and that whole parentheses is raised to a power. In this case, we're going to multiply the exponents. X times y becomes our new exponent attached to that base of a. Power of a product, if we have an exponent outside parentheses, it goes to everything inside the parentheses. A to the x, b to the x. Quotient of powers, again, we have the same base, where the a is the same, and we're just going to subtract these two exponents, a to the x minus y. If that ended up being a negative exponent, like we have here, it moves to the opposite side of the fraction. So here it's going to move to the bottom, because right now it's on the top, and it becomes 1 over a to the x. If it started on the bottom, and it had a negative exponent like this, it moves to the opposite side of the fraction, which means it moves up to the top, and it becomes a to the x over 1. Anytime we have a 0 exponent, or if exponents canceled, remember we're really subtracting these, x minus x would equal 0. Okay, anything to the 0 power equals 1. Now with that in mind, let's do a few examples. And the key with these types of problems is to take them step by step. So when we look at this first example, we have a parenthesis that's raised to the third power. So let's start off by sending that 3 to everything inside the parentheses. First thing to note, when we do 2 to the third power, make sure you don't make this a 6, because it's really 2 times 2 times 2, which gives us 8. Okay, these exponents we're going to multiply because we have power of a power, an exponent raised to another exponent, x to the 15th, y to the 12th. Let's do the same thing with this next parenthesis. Okay, 3 squared is 9. Multiply the exponents, x to the 4th, y to the 14th. Now, for all of these new rules, if it's not an exponent, it doesn't apply. So the 8 and the 9 are not exponents, they're just coefficients. We're multiplying these two things, which means we're going to multiply the 8 and the 9 to get 72. Right, here we have two x's. We're going to put these together. And when we do that, x to the 15th times x to the 4th, we add those two exponents together. X to the 19th, y to the 26th, and 72 is that coefficient. When you have fractions like this next one, it's going to be a lot easier if you simplify the fractions first. So looking at the inside of this fraction, 4 over 8, we can make 1/2. Okay, x to the 5th over x. Subtract the exponent. Make sure you note that there's a 1 on that bottom, which means there's 4 more on the top. When you look at these y's, just make note of where the bigger one is. The bigger y is on the bottom, which means we're going to have y's left over on the bottom. Subtract from the bigger to the smaller. So 4 minus 2, there's 2 y's left over on the bottom. Okay, we still have this cubed outside that we haven't dealt with yet. In this next parenthesis, we can't simplify the 2, but we can simplify these x's. Bigger x is on the bottom. There's 1 extra x on the bottom, so that turns into 2 over x, or I have it written as x to the 1st. Now let's deal with these exponents. So this is going to go to everything inside the parentheses. So 1 cubed is still 1, x to the 12th on the top, 2 cubed is 8, y to the 6th on the bottom. Same thing here. The 2 is getting squared since that's not an exponent. Multiply the 1 and the 2 for the x, 4 over x squared. Lastly, one more step, we want to combine those two fractions. Remember, with fractions, we're just multiplying across. Now you can either put those together first. 4x to the 12th over 8x squared y to the 6th. Okay, and we see that there's x's here that we can simplify. We see that there's a 4 over 8 here that we can simplify. Okay, you can also do that just as you're going. So if you see two x's, one on the top, one on the bottom, as long as it's something on the top, something on the bottom, you can simplify. If there's 2 on the top, you can put them together by adding them. Fractions we would want to simplify. So that would cut out a step, but Either way, we would get x to the 10th, 2y to the 6th. Two more. Here we have some negative exponents, which are going to change where these variables are in the fraction. So since this is a negative 2, this whole thing is going to move to the bottom and become a positive 2. Same idea for this one. It's going to move to the top. So this guy is moving to the top. This guy is going to move to the bottom, and their exponents are going to switch. So we have that now. Okay, now at this point, we can send in these exponents. Oops. All right, so now we would have x to the negative 9th, y to the negative 6th, z to the 6th, over x to the 4th, y to the 6th, z squared. We multiplied all those exponents. And we're going to look to combine everything we can. Now, just like our first step, anything that had a negative exponent is in the wrong part of the fraction. So that's going to move to the bottom. This is going to move to the bottom. Everything else can stay where it is. And last step is put together anything we can, or simplify anything we can. X's go together. Y's go together. We're going to add exponents in both those cases. Z's, we have 1 on the top, 1 on the bottom. We're going to have to subtract. Bigger Z is on the top. There's 4 more on the top. Z to the 4th over x to the 13th, y to the 12th. Take these step by step. Make sure you write out all the steps. Otherwise, you're likely to get them wrong. So our last one here, our last exponent example problem, similar idea for this. So this is going to move to the bottom because it's negative. And it ends up like that. Now let's deal with that exponent on the outside. Make note that that negative 2 is getting squared, which is going to make it a positive. So negative 2 squared is going to turn into a positive 4. These new exponents came from multiplying that 2 from the outside. So at this point we have this. And then lastly, we want to put together everything we can. B's, we have 2 on the top because this one moved up. And A's, bigger one is on the bottom. There's 6 more on the bottom. So that was your refresher on exponent problems. We're going to do a lot of those in class as practice. Here we have some simpler ones. Okay, we have 2 parentheses with a minus in between them, which means we are just combining like terms. So first thing I would do is take this minus sign and distribute it to everything. Right, so it's really minus 8a squared minus 2a and then a plus 8 because it was a negative times a negative. And now we're just looking to put together anything we can. So this doesn't have anything. That's just going to stay as 7a cubed. Negative 3a squared goes with the minus 8a squared. 2a is also by itself. And then lastly, we have the constants. All right, this is our answer. In the middle one, we don't have a plus in between them, which means we are foiling everything out. So we're going to take this n cubed, distribute to everything. And we get n to the 5th plus 4n to the 4th minus 10n cubed. And then do the same thing with this 4. I always like to FOIL from the smaller parenthesis to the larger, but it really doesn't matter. So that gives us this. We would look to put together anything we can, but there are no like terms here, so this is our answer. Last thing in this chapter, or I'm sorry, in this section, is you may be asked if something is a polynomial. The answer is typically yes, with the exception of 2 main things, actually 3 main things, 2 are in this problem. If we see any square roots with variables in them, like this, it's not a polynomial. So the answer for this is no. Okay, if we see any variables on the bottom of a fraction in a denominator, the answer is no. Okay, and this is actually 1 over x cubed. So this would also make it not a polynomial. Okay, if we saw like absolute value of x, that would be another thing that makes it not a polynomial.